And okay, so first of all, applied aspect of two-sample hypothesis. Let me start with a very simple problem. Let's say me and you, we both are sitting, we are, we are chatting on coffee. And the problem comes, we are arguing about the topic. The South Hill Spokane houses prices are higher. And you are saying, no, Liberty Lake are higher. So this is, and you are stuck on your statement. I'm just, stuck on my statement, and we are arguing, and we don't have evidence about that. So now the question comes here, how we can make who is correct, who is not correct, or both are correct, or, there's no difference. So I request everyone to please mute your microphone so that, okay, so this is the situation that two people, me and you, are arguing about housing prices in Spokane, and Spokane, particularly South Hill area, and Liberty Lake house prices. Okay, now we decided, okay, let's do it scientifically. Let's prove it. I am wrong, I am right, or you are right. Okay, what we do? We make an statement which is called null hypothesis, and that says, I'm just writing South Hill housing prices minus Liberty Lake housing prices equal to 0. And second thing, alternative hypothesis is South Hill minus Liberty Lake is not equal to 0. Okay, this is number one hypothesis that we framed. Similarly, there can be a second hypothesis which says South Hill minus Liberty Lake is greater or equal to 0. What is the meaning of this? That means, this is greater than 0, means South Hill houses values are more than Liberty Lake, therefore it will come more than 0. So this is what could be the alternative hypothesis in this case. South Hill minus Liberty Lake is less than 0. Other case could be, third possibility is South Hill minus Liberty Lake is less than or equal to 0. What is the meaning of this? Less than 0 means Liberty Lake house prices are more, and Liberty Lake house prices are more than South Hill, which you can clearly understand from this these simple numbers. And opposite is South Hill minus Liberty Lake is greater than 0. So these are the three possibilities. First possibility, we framed this hypothesis. Okay, there's no difference in the prices. Both are equal. Second is South Hill is high. Third is Liberty Lake is high. Okay, let it be, now. So we frame the hypothesis. Now, second step is, after this, at what level of percent, so by default, I'm just checking this with 5% significance level, or in other words, I can write it, alpha is, so alpha equal to 0.05%. So, or this is. Now, third thing, we should have data. Data. So I'm going to do the data thing. How we can go on Zillow and we can, you know, take randomly data, randomly houses price in South Hill and Liberty Lake. So it doesn't mean, you know, it should be equal. So let's say in South Hill, I'm just going to collect like 79 houses data, and Liberty Lake, I'm going to do, let's say 58. Okay. Or so this is, after that, again, same calculation, same statistics, same hypothesis, and we are going to use. 3 hypotheses are there technically, you know. Now at what level we can do? So on what, you know, so this second two sample hypothesis are based on mean. We can check mean. So we are going to do this simple mean. We can also do on variance. We can also do on proportion. We can also do on, so based on mean, based on variance, based on proportion, and we can also do on paired, you know, paired means, you know, two situation before and a half after. So these are the options. So we are just going to do first very simple mean. Now look into my mini tab. I'm just going to share mini tab. Hope you can see. So this is my South Hill. And this is Liberty Lake. Now I'm just going to use, you know, random number generator to, you know, get the prices. I don't have time to look into Zillow and, you know, so I go under calculate and I have random data. I go under integer and let's put into, what is the column number 6. So, okay, so let me do this 79 entries. What is the minimum value? Let's say in South Hill, nothing is less than 330,000. And I'm trying to hunt the house, but I'm not getting, you know, and, you know, house comes and goes like anything. So nothing is less than this, and maximum is like, I can just put, you know, fair amount like 560,000. 60,000. So, okay, these are the numbers have been created. And 79 numbers have been created here. And you can see, now I go under Liberty Lake. And I don't know about, actually, I'm not, you know, I don't know about Liberty Lake situation, but here I go and I go under this random data and I create the integer and I just use Liberty Lake. And let's say I'm just going to do 58. Minimum value is like 200. I don't know. You tell me. Can I put 289,000 to, yeah, same. I'm just going to put like 520,000. So just, you know, for our understanding, I put these are the prices of 2 places in South Hill. Now, what do I do? So I go under statistics. Under statistics, we have basic statistics. Under basic statistics, we have 2 sample T, and we don't have here, you know, Z test. We have directly 2 sample T test and fair T test. When do we use 2 sample T test? When we have two samples. When you have the sample in before and after situation, like say, what is the body temperature before COVID, what is the body temperature after COVID, or what is the sales before, in two different situations. So this is pair T sample, pair T test, two proportion test. We are not using Poisson. So, this is two variance. So 1, 2, 3, 4. These are the 4 options we are going to use. Okay. So I go under 2 sample and my samples are not summarized. So I have sample 1 is South Hill, sample 2 is Liberty Leg. And then here we have situation which is called this. So 95% hypothesized difference means we are just checking very first hypothesis because alternative is, so first we are checking are they equal or not equal. So this is, now this option comes here, assume equal variance or not. So there are, a manual process in book, but we are going to learn this here. So couple of things are there for checking as equal variance. So I'm just going to hold for a minute and let me share my, can you see my PDF part? No. Okay. Can you see my PDF?
Yep.
Yep.
Okay. So here, how do we see whether the, this is equal or not?
Join the meeting.
And look into this. This is the option under which, when do we assume equal variance or not? So there are a couple of ways to do that. Number one, you just do the box plot. And using box plot, you can clearly see how, these are behaving, both the data, both the samples are behaving. And based on that, you can select equal or unequal. And, this is, don't follow this, I used to do when I was, a student and we did not have computer and all the things. My instructor used, and, that what we learned, sample 1 divided by sample 2 must be more than 2 so that we can assume equal variance, but we don't need to do here. Now we go to the technical part, which is right here. When do we assume equal? Go under ANOVA, test for equal variance, consider normal distribution only if normally assumptions are made. So please see, normality assumption. F test in case of normality, Levant test for without normality, p-value is less than, exactly the same thing that we were doing, p-value, and we can assume equal variance. So let me check, whether, we are having equal variance in this case or not. So before going into this, I'm going to check here ANOVA, and here we have test for equal variance. Okay. And South Hill, Liberty Lake options. Okay, I'm just going to assume normal distribution, and we can see also individual block, and so this is the option. So it saves all your energy, and you can see p-value. What we can decide. So this null hypothesis in this case says, you can clearly see this is the box, the confidence interval Liberty Lake, and this is they are overlapping. And you can, and if p-value less than that alpha, we cannot assume, but our p-value is like 45, what percentage we are getting? P-value is 49%, and alpha by default is 5%. So we can assume equal variance. If that is not the case, let's say I have this data related to our example that I have given for your assignment, fill in the blank, international and domestic bags. So I just go and check this basic statistics, ANOVA. Under ANOVA, we have where is test for equal variance. And let me remove this and let me put these two things. And I think rest are okay. See, p-value is coming. What p-value is coming? P-value is coming less than 5%, which is here you can clearly see. And you can clearly see this is international bag. You know, this is domestic. And you can also see the box plot. This isn't, we can't see, you know, the variation of this and variation of this, they are different. So in this case, when you are doing this, we can't assume equal, but you know, in South Hill and Liberty Lake, we can do this. So I go under again, basic statistics to sample, and both samples, South Hill, Liberty Lake, options, and I'm going to assume equal variance. So you got the point. When do we use this, you know, equal, or when do we use unequal? Okay. Now let's see. So descriptive statistics, like you can understand difference, pooled standard, we are not interested in all. We are interested in t-value, and we are interested in these two. Now, what will you conclude that? Based on this data, p-value is less than 5%. What is your opinion? What is your conclusion? Because we learned this. Any conclusion that you would like to make? Because now you are expert in this. Those, especially those who took my 503. Since p-value is less than alpha value, we don't accept null hypothesis or reject null hypothesis and accept alternative hypothesis. That means mu1 minus mu2 is not 0. That means they are different. Means their mean prices in South Hill and mean prices in Liberty Lake are different. Now, this is the first hypothesis we have just checked, and our conclusion, you know, our debate about, you know, you and me, we were debating. Now that is over. First point has been over. You know, this is not equal. Now, who is correct? I'm saying South Hill, you are saying Liberty Lake. Who is correct? Let's check. So now next option, I'm going to do exactly same thing. We don't need to do, we only want to change the option under, why this is taking, okay, Liberty Lake. It is taking, okay. Now second option, look into this. Difference is less than 0. This is alternative hypothesis. That means what is the original hypothesis of null hypothesis? Difference is greater than or equal to, greater than and equal to 0. And alternative is less than 0. That means this hypothesis is going to demonstrate whether South Hill is higher or not. So this is my thing, and I just clicked here. So here you can say this is 0 and this is less than 0. That means alternative is, this means Liberty Lake is higher in this case. And if alternative is proven, what is the p-value? what is the p-value? P-value is more than 5%. Now, what is your conclusion? You just tell me. I'm expecting your conclusion. Yeah, in decision rule, in terms of decision, what would you conclude that, who is, I am correct or you are correct? I mean, we were having a debate. What is the conclusion of debate? Liberty Lake is higher. Think one more time. South Hill is higher because our null hypothesis has been proven. Null hypothesis is correct. That means mu1 minus mu2 is greater than, and that is 0. That means if p-value is greater than alpha value, that means we accept the null hypothesis, and this null hypothesis is accepted. Look into that, another way to look into this. So here we can go. We don't need to change, only I just change this. Difference is greater than, hypothesized difference. Means difference is greater than 0. That means this is alternative. So look into this. And here p-value is this. So you check that or you check that, in both cases, Liberty Lake is lower than. So the conclusion is made that South Hill price, we were having a debate, blindly on coffee table. And finally, using our Zillow data and our statistics, we come to know, no, South Hill is more than Liberty Lake in terms of housing prices. And this is done. And then, the debate is stopped. And then, on the other side person says, okay, oh, that's fine, because this is a scientific. So this is the one application that you can apply throughout any situation. Sales in two store, you can apply, for example, salary of your salary, Washington state employee salary or Oregon state employee salary. You can see, Washington State University professor, Eastern Washington University. Think about n number of applications that you can apply using this. And when you have a real data, I mean, I just made this dummy data and, just random data, you can really do the wonders in using two-sample hypothesis test. What we have more than two sample test, more than two sample, what we will do? For more than two sample, we use ANOVA. What we do? We use ANOVA. And ANOVA, I can just demonstrate, then I'm going to go over technical part. So let's say, for example, this is but we are not covering ANOVA in our assignment. I'm just giving you knowledge so that you can, because you are saying, okay, we have one sample test, we have two sample. What we have more than two sample? In that case, for example, I'm just going to consider third, baggage, which is this, and I'm going to create a data set, calculate, and where's a random data integer, and I'm just going to do row number, let's say 34, and 20 and 58, and store in a column enter. Okay, for example, I have three set of bags. For example, I have these three data set. How I can check, for example, I just go under stat, basic statistics, and ANOVA, analysis of variance. I'm just going to use one way ANOVA. And let's use this. All three samples, 1, 2, 3. Okay, we have options here. We can assume equal variance or we can't assume because they don't have equal variance. So I'm not going to assume comparison. We have different, but for just simple, so we have three. What it says, null hypothesis of this, all means are equal. Means if you are going to check this South Hill, Liberty Lake, and for example, let's say Medical Lake. So three, and in that case, Medical Lake, and we are going to check null hypothesis that all prices of all three areas are same. And the alternative says not all means are equal. So basically exactly same way of hypothesis. So in this case, I think we have done. This is 3 and look into p value is, which is less than 5%. P value is less than 5% Bell test. Look into, simply you can visualize this. Simply you can visualize this, diagram that explains you the whole story. You can see, this is one international, this is domestic, this is they are all, they are basically, they are not having all same. This mean is here, this is here, this is here. So you can say this is a box plot of all three. We can clearly understand that this hypothesis is not proven. Means null hypothesis is reject, which is all means are equal. So, and the alternative is correct. Not all means are equal. That means at least one is out of the, maybe, so what you can do, you can just remove that and you can compare rest of them. So this is ANOVA technique, which is used if you have more than 2. Now let me get back to our slides part. So now since this is the mini tab started, I just made this space, these slides, which explains the clear mini tab instructions on this. So how we can check, where you can see these things, 2 sample, this, 2 variance. These are the 4 options out of which you have to pick up. And again, exactly the same rule, p value is less than or higher than. Based on that, you are going to select null and alternative hypothesis. These are the steps that you have to follow. Exactly same, which I'm just explaining right from the beginning. So these are the steps in order to check the hypothesis. And these are the questions which are right here in this, for example, I just shared difference. And so this is hypothesis testing. Similarly, hypothesis testing can be based on variance. Now, look into the, case of variance. What is the meaning of variance here? So for example, now my question is that South Hill and Liberty Lake, which, where is the most variance, or, are the variance of South Hill housing prices and Liberty Lake housing prices are equal? I go under statistics, I go under basic, I go under 2 variance, and I can pick up sample 1 is South Hill, Liberty Lake is this. Options. Ratio is not hypothesized ratio, which is 1. Why we use? So use test and confidence based on normal distribution. Again, so we have to check, normality and equal. You can see the variance South Hill. And this is a confidence interval. These are the other things. Look into the null hypothesis. Sigma 1 means South Hill. divided by where, Liberty Lake equal to 1, and alternative is not 1, alpha is 5%. You can see these methods. If you put, normal distribution, for example, I'm just going to do, and that you have to check with whether they have normality. So in that case, F test will be right here. So F values that we already checked, that 49%. 49% their variance, we already checked in this case, equal variance option. So this is a p-value. So what is the meaning? Null hypothesis is accepted, means their variance are equal. We can assume equal variance. If suppose the p-value, which we have already tested in this and this case, so this is the case of testing the variance. Similarly, you can test for proportion. We can round up the p-value in a situation. For example, p-value is, no, you have to put exactly, 0.491. 49%, just put 0.491 if question has been asked. So this is the case, similarly, you can do for proportion. I mean, I don't have here the data about proportion, but you can, simply do the proportion using statistics. And don't forget to do, whenever the question has been asked, some questions are there. Paired sample t-test, paired sample when you have this two situations, for example, weight before COVID and weight after COVID, patient weight. So randomly taken weight of 50, COVID patient before COVID and after COVID. And do you see any, that is a case of paired sample t-test. So in that case, basic statistics and paired sample t-test. So I'm, for example, I can, form this South Hill housing prices before COVID, South Hill prices after COVID, which is certainly increased. So you can see, you can use the paired sample in this case. So I'm just going to, put the data. Don't, it has to be only South Hill, and it will give exactly the same, almost same answer. Second sample column. Each sample in a column. And the following must be the same. Okay, yeah. So for example, when you are doing the paired sample, it has to be the same number of observations. We have different here. So paired sample is always the same, but otherwise the sample can be different for different samples. So this is about, two sample hypothesis test, which I wanted to explain, and you can do it. Rest you can do it very easily. Any question, if you have, please let me know. If no, I would like to say, what is the question you have on homework?
Hi, sorry, I was trying to unmute. I am struggling to find a certain, hold on, let me pull it up. I think it's a P or T value on number 16.
Mm-hmm.
And 16 references, I believe, the weight in pounds of the suitcases.
So T value you are not able to get?
No, excuse me, it's the test statistic. So yeah.
Test statistics basically a t-value,
Yeah, I know, I misspoke, sorry.
So for example, this is 2 sample t, and let's say this is, okay, this is the, okay. And what is that? Okay.
So the difference is greater than or equal to 0. And 3.7. I've tried that.
Is it not working?
But I might have tried negative 3.7 for some reason. That's what I had written down.
Just a minute. I mean, I don't know. I mean, I don't remember the question. What is the question? Please try to think clearly. What is the question asking? Is it asking test statistics, or is it asking the t-value of critical value of t? For example, how in 2sample, how you do degree of freedom? For example, I'm just going to degree of freedom in 2sample equal to, for example, here 23. How? Because this is 10.
Yep, minus 1.
And plus this is how many? 15 minus 1.
Yep, so 9 plus 14.
So this is same, whatever number, so degree of freedom. Now you need to see the critical t value. So go under graph, probability distribution. And I just choose here t value, degree of freedom. What degree of freedom? 23. For example. Okay. And now, so this is one-sided, this sided. Now, this is only, right side test. If you are going to split into 2, how much it is going to be? So again, you look probability. So again, and shaded area. So I do it again, and this would be minus. Now, if I going to do both tail test, which is equal or not equal, then this case. So I mean, this way you can get the, if question has asked you to put the critical value, then critical values are these values. In what sense and what situation? And
I'm sorry, it's asking for the test statistics. I feel like I'm not understanding what you're saying.
Test statistics is coming directly from the Minitab, which I just showed to you.
Okay. Okay.
I mean, all the test statistics, like, for example, our this Liberty.
So test statistic depends on the distribution, not on the data, right? That's the value we compare to.
Yeah, so this is, for example, let's say, this is test value. For example, just look into this. And since, we have a p-value, it's easy and simple to use p-value to reject or accept your hypothesis. Therefore, we are not going to look into that. But we can do also, let me show you, demonstrate you the test statistics. So this is coming 3.70. Okay. Now look into the distribution plot. When it is accepted, when the value is between minus 2.069 to plus 2, any value in between these two numbers, then our null hypothesis is accepted. That says, international domestic flights weight are same. But since our test statistics is coming 3.7, that would be somewhere here, if I'm, somewhere here. That is in rejection region, and automatically we are, rejecting this hypothesis that, they are not equal. So similarly, you can, calculate this, this critical value and that test statistics are to make the decision. But if you have p-value, you can make it straightforward. You can if you know the concept, if you can understand very well why the p-value and what is the critical values, you can easily do that.
Okay. Just to be clear, 3.7 is the test statistic in this scenario, is what you're saying?
Yes, exactly.
Okay, and I did try that on the homework, and it's not working for number 16.
Okay, so I have to check that, you know.
Okay, so that's all I was checking, and I'm glad, because I was getting a little confused, but the test statistic and the t-value with the luggage question, I have 3.7, and I've tried it a few times, and it just didn't work, so.
Okay, so just a minute. I mean, wait a minute, I'm just going to check. Question number 16.
Yes, please.
What is the test? Just 1, 2, 3, 4, 5, 6. So it is exactly international luggage question.
It's number 16. It's underneath the luggage question. Yes.
Okay. What is the test statistics? Okay. Oh. Yeah, that is, you know, something I don't know how. Okay. No, that's the different thing. Okay, just a minute. I have to double check where. So the question is asking, is international option, and it is 95% clearly?
Yeah.
Okay. Oh, probably.
The mean weight of the international bag is greater.
Okay. So okay, so there are, you know, now, yeah, we have to see, you know, I was just, so look into the, can you see this?
No.
Can't you see my Minitab?
I see it, but are you doing anything?
No,
oh, okay.
Okay, look into the Minitab. Thus, the problem is that, you know, I did 3.7 with assuming equal variance. Since you have to test, so for example, we have checked in international domestic, their variance are not equal. So we have, you know, in assuming variance, we were getting 3.17. But if you don't do this, then you get this value, which is correct. So by default, you know, the calculation which was coming. So this is the difference between assuming variance equal and not. So you have to test before doing the hypothesis test, whether the variance is equal or unequal. So the correct answer is this.
Okay, thank you.
Yeah, so always be careful. You know, this is the small box that you are going to use. but this small box will make a lot of difference.
Would you run through that variance test one more time?
Okay, for example, here we have statistics, ANOVA, and you can see test for equal variance right here. Under this, I'm going to also supply these things so that you can have, because I put everything right here. Because some of the students joined this course, they did not take our BADM 503. For them, it's so. Yeah, so I did this option. We have use based on normal distribution, since, we can check whether they are normally distributed or not, since, this, and you can see this. P-value is less than 5%, and it is also less than 5%. Both, live and test, because it is, we can't say one sample is 12 or 10, so we can't assume normally in 10 sample. So you can clearly see this is not normally. Here you can see all variants are equal, null hypothesis. Alternative, at least one variance is different. And look into this. So all variance, so if p-value is greater than 5%, then we can say all variance means this sample, they are all equal. But since it is less than 5%, we are saying at least one variance is different. That means we have only two samples. That means at least one is different. That means both are different from each other. Making sense?
Yeah.
Okay. So any other question?
I have a question. I asked it earlier in the chat and Mike tried to help me answer the question, but I have a Mac, so this isn't working when I try to go into virtual labs and copy the information that's in the Excel document. So
Okay.
how do I go around fixing that or working through that, since I don't have access to Minitab on my Mac since I already expired the license during 503?
No, you can have, the license can work till, end of the July 31st of 2021. Probably you just installed you did not put the license file, and therefore it just worked for you for a month and it got expired. Or you can just uninstall and install, and there's a license file. I'm going to do it. Give me a minute.
Okay, but still, if I know the actions are limited on a Mac, so how do I copy the charts into the virtual labs if it's not working when I copy from the Excel document and paste it in there?
So basically what you need to do, you have to just, everything you need to open in you need to open the assignment, you need to download your, this in virtual lab browser, this Excel file, and you can copy, and all the actions like you do on your computer, same you can do on virtual lab computer.
So they changed it that it's through an Amazon browser. It's not a separate browser like it used to be, unless there's another way to access it, but I accessed it based on the information that was in the resources we had in this class. I
mean, for more, because I never used, virtual lab and Minitab together, and I never worked. So probably I would suggest you to just, go to EWE IT help desk, and they ask me to just send any student, if you have any problem, you just can go to EWE IT help desk and they will help you instantly.
Okay.
That is the, best option.
Sure. And so if I uninstall the Minitab, then I can just reinstall it again and have access for 30 days again?
No, not 30 days, till 31st of July 2021. Means almost 5-6 months you will have still.
Okay, and there's a license. I'm sorry, if I missed the license document on...
Exactly, this happened. Most of the students, they miss the license part, and therefore that lasts for just one. Just go under, our before module 1, there is a complete instruction, complete page, and at the bottom of that page, there is a, okay, I can just show you. Yeah. Yeah, right here, Victoria has shared. So on the bottom of this page,
we're just seeing the mini tab right now. It's not showing the page.
Can you see this?
In the chat window.
Oh. I mean, just to give me a minute. Where am I? Can you see now?
Yeah.
And this is the license file. Clearly, you need to download. What happens, people do, they install and they just go click, 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 and done. And that is 30 days. But if you do this, you can clearly see on the top, it is good through 31st July 2021.
Okay, great. I appreciate it. Thank you.
You're welcome. Yeah, Ruben, that has been addressed properly, and the university has said there is no problem. In case if you come across any problem, they ask me to just ask a student to just approach them, and they will help you as much as they can. Because I can see, Ruben, that some of the students scored 100 out of 100 in the so if some students can score 100 out of 100, means there is no problem. Okay.
I actually did have one more question. I'm sorry. Do you still have time, or do you want me to meet with you tomorrow?
No, just let me know if I can answer.
Okay, it's actually about the discussion question. And I'm with the final question on here. I was kind of hoping, in a generic sense, you could give me an example of the first, the second, and the third, just like even in relation to real estate or something, because I'm just having a hard time correlating the variance and the unknown variance and the equal part in all three of these. I was hoping you could give me a little context or an example of these, and then I can apply them to my work, because I'm just struggling with understanding it.
So these are the technical, most of the questions. And, I already shared the example of, about South Hill and Liberty Lake. When you go through the, reading of the entire chapter, you will come to know about, these are the technical. When you read and study, then you will get more understanding. So why two samples from same population could differ?
Not that one. I meant number 4 specifically.
List 3 cases that you observe of your professional life for comparing two means and explain how they differ. The first one should be of known variance. The second one should be unknown variance, but equal. And third one should be unknown variance. And so basically we have just looked into our cases, known equal variance, unequal variance, and known variance. So known variance. So, we have just looked to, and that, the known variance, the income, you can say the known variance of whatever you are doing. So think about the situations where the variance is known, this could be the variance when, the student is coming to Eastern Washington University, the income can be known, the variance of the income, most of the therefore, or different aspect could be there. Or so basically, professors where, the variance of the salary is, almost known in Eastern Washington, Western Washington, or, so throughout the Washington state, the salary of the professor is almost same, I believe, in, state universities.
Yeah, okay, so that's the one with the unknown variance. That makes sense. So with an unknown but equal variance, I'm having a tough time figuring out. I just was hoping you could give an example, like as it pertains to you, and it might click for me in my field.
I mean, I don't know your field, to be honest, but...
Yeah, I know you don't know my field. I'm asking for you to put it in context for yourself, to see if maybe it will click for me personally in my own walk of life.
Yeah, just, I mean, I leave this up to you to think, what could be the case, because you have already done VADM 503. And by this time, I believe that everyone should have, should have clear thinking about this. What is unknown?
I can maybe set up some time with you tomorrow. That's okay.
No, I can answer in a quick 5 second. I mean, that is not a big issue, but I want you to think.
I'm trying to think. That's why I'm here.
Yeah, keep thinking. I mean, and I'm not very hard and fast in if, I will see your answer is not appropriate, and, I will share my feedback over there.
Okay.
I want to give you little, little critical thinking, because this course is not about tech, Minitab. It is about more critical thinking, and that where we are, a small mistake, small things can change the number and everything. Like, we were doing t-test, and, the assume equal and unequal, that changes the thing.
Okay.
Okay. Okay. Any other question? If you have, please let me know. If not, I would like to say have a good night and see you next Wednesday. Bye-bye.
Thank you.
Bye.
Thank you.
Thank you.
Bye.